Jeff Kim. I'm the Chief Operating Officer and President of CDNetworks. We have been faithfully serving the gaming and gambling markets for over 13 years now. We have about over 18,000 web properties who we serve, and we serve over billions of transactions, DNS, HTTP, HTTPS, TCP transactions every day. But I'll talk a bit more about the company and how we serve our. Overall, this is a huge market. Has been for business 13 years that we've been in the business, and it continues to grow. Obviously, this is and the transition of downloadable executable games into actual real-time experiences, both on the gaming and gambling sides, are starting to increase adoption more. It's also global, with China coming online, with the emerging market, South America growing, with the adoption of tablets and global industry growth drivers. Again, we talked about cross-border, being able to see the traffic growth and the growth of our customers from our vantage point. I can tell you that a lot of our business is about going global. You start in one market like the U.S. or in Korea, and as their business grows, as their platform, their software starts getting adoption, global traffic drives customer growth significantly. We have customers that have started out with us with thousands of transactions, and within a year or two, based on their success, they've gone 1,000 times where they started off from, and that's not an abnormal or irregular story. High-speed connectivity. This is an area where our customers, again, the more as broadband gets adopted all over the world, sophistication of both games and gambling sites continues to just embrace the ability to send more types of interaction out to end users. Sophisticated gaming techniques. Some of the best technical teams out there are actually in this sector, surprisingly, more than teams in, let's say, e-commerce or enterprise. Some of the customers that we work with specifically in the gambling and gaming sector have teams specifically on web performance, CTOs and CIOs that are laser focused on this and that have better knowledge of the space than some of the folks that we meet at like Facebook or Google. So the adoption of new real-time techniques, web performance, internet infrastructure is very high in this space. And with all the competition and growth, it continues to grow, as well as the last point, things are opening up even more, specifically in the regulation and government. Even in the U.S., that used to be very tight on gambling. It's starting to open up, and people are predicting within the next few years that it'll be more. The PC era is moving to the mobile era. Obviously, you have to have an experience for the laptop, for tablets, for mobile devices, and that's not changing. That's online gambling markets. These are a list of different countries and regions where it's allowed, and it continues to grow year after year. So a bit about CDNetworks. We are in the global cloud acceleration space, and we'll go a bit into that because for a lot of people, cloud means everything and nothing at the same time. We're really focusing on leveraging the internet into this application, but now it really is an interactive medium where applications can be run on top of. We're very good at partnering with our customers in local markets, but really our differentiator and our expertise is about extending into global markets, serving both gaming and gambling, and we have some of the best brands out in the marketplace today who we're serving. Our network presence. So this is kind of one of our keys to our service. We have 140 points of presence around the globe in 81 cities. So we have 25 points of presence in China, 13 points of presence in Russia, dozens of points of presence in U.S. and Europe, and we're Southeast Asia, Latin America, and it continues to grow. And what we do is work for our customers and our partners, taking their gaming and gambling app to a certain data center and accelerating it through our network of 140 POPs. Overnight, basically, our customers have access to 140 data centers around the globe where they can extend their single dual data centers for disaster recovery out into the world. We have a full suite of products. We call it the Web Performance Suite. There's a bunch of different components in there, from accelerating dynamic transactions, of course, caching regular content, being able to serve videos and media, storing your content. There are things like DNS, which is another core key thing that every website requires, that we put into our cloud and allow our customers to leverage. So let's go specifically into the problem and how we address that problem. So the problem with web first is internet latency, right? So if you have a data center there located in San Jose, roughly to go from coast to coast in the U.S. takes 50 odd milliseconds. As soon as you go to across the ocean to London, it's 150. You go to Beijing, it's 500 milliseconds. Okay, and that's for one transaction to happen. Along the way, in step 2, there are network problems. There's still packet loss, congestion, retransmissions, things happen. And then finally, the internet, as we use it today, is based off of a 40-year-old protocol. So TCP/IP was originally designed in 1973. And here we are 40 years later still leveraging this and pushing it to do things that we never really ever developed or designed it to do. So TCP is a very chatty protocol, meaning in order for, in this particular diagram, for that green payload, which is the content or whatever you're trying to transmit across, in order for that to get across from your data center to the end user, there is a lot of build up, tear down, checks back and forth, a lot of things going on in the middle to make the actual transmission or performance very slow in this chart. So in this particular thing, we have we have a 24 kilobyte object, and the data center is in Washington, D.C. And as you'll see, to download this 24K object from Philadelphia, Atlanta, Boston, Chicago, it's relatively okay. But the farther and farther you get away from that for this little object, and you see on the right-hand side things like Shanghai or et cetera, all the way to the right, you're 14, 30, 50 times slower than what you originally started. A lot of customers, we find, think that this is a bandwidth problem, that if they go out to their telecommunication provider or their ISP and buy better bandwidth or buy better connectivity, it will solve this problem. It will not. And we actually have a white paper on our site that mathematically shows that just because of how the protocols of the internet work, that you will always fundamentally have this problem, leveraging the internet to deliver your application. So how do people and how do our customers typically try to solve this problem? First and foremost is adding more data centers. So this is by far the solution that most of our customers are contemplating before they come and talk to us. So they have a performance problem in China. So they say, okay, let's try to put up a data center in Hong Kong, or if they go through the regulations of getting licenses in China, in Beijing. Well, obviously this is quite expensive. You have replication problems between everything, and be quite honest, one data center in a far-off location does not solve your performance problem. We'll take for Russia. Russia covers 9 time zones and is a vast geography. And actually, the internet in Russia is actually quite poor. So putting one data center in Moscow will increase your CapEx and OpEx and cause you loads of technical problems and will not solve your Russia problem. Same thing with different regions in Southeast Asia, Latin America. So data centers and adding more colo and more pipe will not solve your problem. Secondly, a lot of folks put hardware appliances. Well, actually, in this specific market, this doesn't work. Hardware appliances work very well from a point-to-point branch off if you have a fixed location. But if your end users are, as we said, mobile and logging in from all over the globe, you can't put a hardware appliance everywhere. Actually, that's kind of what we've done. We put a hardware appliance everywhere where end users are. And the other solution that we see a lot of folks do is traditional CDNs. So a lot of people define CDNs as caching, and that's actually where the industry started with. So there's a bunch of traditional CDN players that will cache your content, whether it's video or your JPEGs or your logos, and offload that content from your origin. This worked quite well for some. In fact, some in the gambling industry leverage this because to take advantage of some of the tax benefits of certain regions or locations, they've put their businesses and data centers in these tax beneficial locations. Unfortunately, telecom and ISP providers in these locations have very high rates because they know that gambling companies must host their site there. So a lot of gambling companies actually went with traditional CDN vendors to lower their bandwidth costs from their local ISP or telco. But that was a cost-saving measure. It wasn't necessarily a web performance measure. Also, in the gaming market, when games used to be very download to your PC and kick off your EXE, and then play from the end user plays from their machine. Again, caching was very beneficial. But in both of these markets, both gaming and gambling, things are again with the growth of mobile, with tablets, with social networking, with real-time internet technologies. A lot of these things are no longer dumb downloads that you run off of the computer. Everything is real-time. You have AJAX and JavaScript calls and JSON calls and real-time APIs and beacon functionality that sends one packet back and forth. That traditional CDNs are not able to handle. So caching doesn't solve the problem either. So what does CDNetworks do? We've already talked about the traditional problem where you have an origin data center located somewhere in one location, but remote end users coming in from all over the world. Application performance is poor, unhappy users, and again, in the competitive market, you need a very strong user experience. What we've done is, using our 140 points of presence, we will undoubtedly have a POP near your origin data center, and we will have a POP somewhere near your end users. And what we've done is we've created our own optimized protocol in between our points of presence. So while we cannot fundamentally change how the internet works, we can change how we transport data in between our POPs. Furthermore, what we've done is we're still able to leverage caching techniques so that the pieces of your web application or website that can be cached near your end users. But the dynamic calls, the real-time transactions, can get on our accelerated highway in between. A bit more into the technology in between. We've already talked about the problem, RTT latency, network problems, inefficient protocols that really slow things down. With our solution, we capture all of those inefficient back and forth near the data center and near your end users, and the long haul in between is really optimized just to send content through. We're able to do this because we're constantly monitoring the internet. We know how much we can basically jam through the internet at once, and that's what we're doing. We're maximizing throughput. Furthermore, if there are problems on the internet, we route around them, and there are a bunch of techniques that you'll see on the left-hand side that we leverage to be able to really make the internet a high-performing application platform. So what does all this technology mean? Well, in this particular graph, we're using Gomez, which is a third-party web performance monitoring tool. We take a single 40 kilobyte object, which is somewhat small, and after they light up, leverage our services, we're able to decrease that down to 50, 60 milliseconds for that single object. When you take your gaming experience, which is made up of dozens, if not hundreds, of calls back and forth, and objects moving back and forth, this adds up quite a bit. So we're seeing hundreds of percents of performance improvement. Okay. We also, because of our vast network, we are able to protect your origin and your web property. via our security services. So as you can see on the left-hand side, the typical attack is about sending a volume-based attack, whether it's at your DNS infrastructure, your web infrastructure, your SSL infrastructure. It's about just massively inundating your existing data center or infrastructure so that it cannot handle any more transactions. Okay. There are different types of attacks out there that the bad guys are using, and they're listed there, from UDP floods to ICMP floods to SYN floods, etc. There's all sorts of different techniques and new ones that are popping up every day. And both the gaming and gambling sectors are actually very prone to attacks. I mean, historically, have always been that case. So what we do, again, for our customers, is by leveraging our 140 points of presence and our massive infrastructure out there, we first absorb, and that's our first line of defense. By shielding your origin data center with our network in front, we absorb the attack. Then, of course, we detect it. And then we work with our customers to figure out, is this a real attack, or is this just a launch of a new game? We don't want to, illegitimately filter out, good traffic. So we come up with specific rules and a process that we work with our customers on. And then finally, we defend. This obviously is filtering, mitigating, and filtering out the bad traffic so that the only good traffic goes through. Okay. So let's talk about a specific case study. One of our customers is the largest online gambling company in Europe. We also happen to have the largest video gaming company that's currently on Facebook as well. But we'll cover the gambling one here. They're located in London. They're focused on online gaming and betting. Millions of pounds a year, millions of bets a day. And obviously, they have both dynamic and static. As we talked about before, it's no longer just a static world. It's really about personalization, interaction, interactivity, etc. They have a complex website, dynamic content, data-driven, and again, very complex internet and web techniques. Of course, their main data center is not located near all of their end users, and their end users are globalizing more and more. And bandwidth costs were a problem for them as well. And their global site was not meeting their users' satisfaction. Okay. So they were using actually a traditional CDN for caching, but as we mentioned before, that did not solve their web performance problems. It solved some of their bandwidth reduction problems from their origin data center, but they were still having major issues with performance and reliability. So they wanted global reach and a CDN that had the operational knowledge of both dynamic and static. So they went live with CDNetworks over a year ago, and as we mentioned, I mean, again, global coverage, stability, high performance, and delivering a high level of customer support for themselves as well as for their